All right, we are collecting data for the calorimetry lab. This is for unknown metal cube number 1. I'll be going through and collecting the data. You can follow along and fill in the data table as we go. The first thing we're going to do is get the mass of the calorimeter water. So I have here a total of 100.0 plus 98.0 is a total of 198 milliliters of water. And because the density of water is 1 gram per milliliter, 198 milliliters of water is also 198 grams. So mass of calorimeter water is 198.0 grams. Next thing we need to know is the initial temperature of our calorimeter water. When we're taking temp, we always want to give it a minute, make sure it's not moving anymore, so we are taking in an accurate temperature. And it looks like this is staying steady at 22 degrees Celsius. So initial temperature of calorimeter water is 22 degrees Celsius. The next thing we need is the initial temperature of our metal cube. We cannot measure that directly. We can't stick a thermometer right in the middle of that metal cube. But it has been sitting in this boiling water, and we know that as it sits in the boiling water, heat transfer happens between the metal cube and the boiling water until they reach an equilibrium, until they are at the same temperature. So we can measure the temperature of the water and assume that's the same as the temperature of the metal cube. So let's go ahead and do that. We could also assume that this water is at 100 degrees Celsius, but because it's not at a really rolling boil, I'm going to get a more accurate temp by taking that temperature. So it's still climbing, so I want to make sure I give it a minute and take an accurate temperature. Okay, and it looks like it stopped at 97 degrees Celsius. So the initial temperature of the metal cube is 97 degrees Celsius. Now I'm going to transfer that cube over to the calorimeter. Do that as quickly, as efficiently as possible. Get the lid back on so it's as insulated as possible, because we do not want to have heat transferring between the calorimeter or the cube and the environment. As we wait for this temperature to stop climbing, we can think through sources of error. So what are some things that could affect our data collection, could affect our lab and make it less than perfectly accurate? Could we have lost heat in the transfer? That's probably a pretty big one. Is this calorimeter not perfectly insulated? Could there be heat transferred, lost, or gained from the environment to the calorimeter? What's happening inside the calorimeter right now is the hotter metal cube is transferring heat to the cooler calorimeter water until they reach an equilibrium, until they come to the same temperature. So again, we want to make sure we wait for a while for this. Make sure we get an accurate final temperature so that our calculations, our final number, is as accurate as possible. Right, the final temperature of the calorimeter water and the metal together was 29 degrees Celsius. Last piece of data here is the mass of this unknown metal number 1, and that's 90.8 grams. So go ahead and use this data to calculate your specific heat of the metal cube and identify it.